Hey everyone, and welcome. Today we're going to dive into a technology that is quietly but completely changing how we find and use information. It's called vector search, and it's basically the secret sauce behind the AI that feels like it actually gets you.
I mean, we've all been there, haven't we? You type something into a search engine, and you get back a list of links that, yeah, they have your words in them, but they totally miss the point. They don't understand your intent. This question gets right to the core of the problem that vector search is here to solve.
All right, so before we can really appreciate the solution, we've got to understand the problem. So let's start with the kind of search we're all used to, good old keyword search, and see where it falls short.
And this slide just nails it. Look at the difference. With a keyword search for smartphone tips, you get, well, smartphone tips. It's super literal. But look at semantic search. It understands what you mean. It knows that mobile device tricks or cell phone hacks are basically the same idea. It gets the concept, not just the string of letters.
And that's really the heart of it. It's what people in the field call the semantic gap. At the end of the day, old-school search is just playing a game of match the letters. It has no clue about context or the actual meaning behind the words. And that's exactly why search can sometimes feel so clunky and frustrating.
So how do we fix this? How do we build a bridge across that semantic gap and teach a machine to actually search by meaning? Well, the solution is actually incredibly elegant.
The whole thing kicks off with something called vector embeddings. The best way to think about this is like a universal translator for ideas. It takes anything, a word, a whole sentence, even a picture, and turns it into a unique numerical fingerprint, a vector. In this new language of numbers, concepts that are similar, like car and automobile, end up with very similar-looking fingerprints. That's how the machine starts to understand relationships.
Okay, great. So now we've got these amazing numerical fingerprints for everything. Where do we put them? That's where a vector database comes in. It's not like your typical database. It's a purpose-built library designed specifically to hold all these complex fingerprints and, most importantly, to search through them for similarities at unbelievable speeds.
I love this analogy. Just picture a gigantic map, but instead of places, it's a map of ideas. Concepts that are really similar, like king and queen, are plotted right next to each other, like neighboring cities. But unrelated concepts, like king and, banana, are on totally different continents.
So we've got this incredible map of meaning. But how in the world does a computer search it so fast? How does it navigate this continent of ideas in milliseconds?
Well, checking every single point on that map for every single search would take forever. It'd be like trying to find someone by knocking on every door in the country. So instead, these systems use a really clever shortcut called approximate nearest neighbor search, or ANN. The keyword here is approximate. The goal isn't perfection. It's about being really, really good and finding the closest matches, but doing it almost instantly.
Now, there are two main flavors of this, and this slide lays them out. On one side, you've got HSNW. Think of this like a super efficient multi-level highway system for your ideas with express lanes and local roads. On the other side is IVF, which is more like a super organized digital filing cabinet where it groups similar ideas into folders. And there's a trade-off, right? HSNW is often blazing fast and finds better matches, but IVF can be a lot more efficient with your computer's resources.
So let's dig into HNSW for a sec, because it's pretty clever. It starts its search on the top-level freeway to get to the right general area really quickly. Then, it takes an off-ramp and drops down to the more local roads, zeroing in on the most promising candidates. It's just a brilliant and efficient way to navigate that giant map of meaning we talked about. Okay, so this isn't just some techie fantasy or a lab experiment. This stuff is out in the wild, right now, powering some of the AI you're probably already using. I mean, just look at this list. It's a who's who of tech. You've got the huge cloud providers like Google and Amazon, you have the big data platforms like Databricks, and then you have companies like Pinecone that are all in on vector databases, plus major open source projects like Milvus. The entire industry is betting big on this. But here's where it gets really game-changing, especially for AI. One of the biggest problems with large language models is that they can forget things, or worse, just make stuff up. Vector search helps solve this with a technique called retrieval augmented generation, or RAG. It's like giving that super smart LLM a perfect, searchable, long-term memory. So check out how this works. It's like a simple four-step dance. First, you ask your question. But before the LLM even sees it, Vector search zips over to a knowledge base and retrieves the most relevant facts. Then, those facts get bundled up with your original question. And finally, the LLM uses all that fresh, accurate context to give you an answer that's actually based on facts, not just a guess. It's how you stop AI from hallucinating.
But you know what? We're not done. This is all amazing, but it's really just the beginning. The next frontier is all about making these meaning-based searches even smarter and more specialized.
This quote from a recent Google research paper kind of hints at what's next. What it's basically saying is that the general all-purpose embeddings are great, but if we can fine-tune them using data from a very specific domain, we can get a massive performance boost.
So what does that actually mean? It means we can go from a jack-of-all-trades map of meaning to a true specialist. We can create a version that's an expert in legal documents, or another one that's a genius at understanding scientific papers. We're moving from general knowledge to deep, expert-level understanding.
And this chart right here, this is the proof. On a tough scientific fact-checking test, the standard generalist model, that's the zero-shot one, did okay. But the custom-tuned search adopter model was significantly more accurate. Now that jump from 0.72 to 0.79 might not look huge, but in the world of AI accuracy, that is a massive win. So this kind of leaves us with a really big, kind of mind-bending question, right? For our entire lives, we've been training ourselves to ask questions in a way that dumb keyword search engines can understand. But now that search is finally starting to understand us, our intent, our ideas, what new kinds of questions can we even dream of asking? What new things will we be able to discover?